तो आज हम सेंट्रीपिटल फोर्स के बारे में पढ़ेंगे। तो ये फोर्स तब लगता है जब पार्टिकल सर्कुलर मोशन में हो। यहाँ पे देखते हैं, जैसे पार्टिकल है, इफ़ आई हैव टू ड्रॉ velocity at this point, so velocity will be at in the direction of tangent, right? So here velocity is in this direction. If I want to draw velocity here, so it is in this direction. Here something like this, tangential in the direction of tangent, here like this. So now see here, the direction of velocity is changing, right? So now see, velocity direction is changing. So if velocity direction is changing, that means some force is there, right? Because force is what, or acceleration is what? Acceleration is what? Change in velocity, right? So here velocity is changing, that means some acceleration or some force is there, right? So here the force responsible for this circular motion is none other than centripetal force. So centripetal force, it is, or I am writing like this, centripetal force is responsible for circular motion, right? Now here I am writing that this is very important. This is not a new force. इसका कहने का मतलब ये है कि सेंट्रीपिटल फोर्स कोई नया फोर्स नहीं। अभी तक हमने जो भी फोर्सेस पढ़ा, जैसे टेंशन, स्प्रिंग फोर्स, ग्रेविटेशनल फोर्स, कूलॉम्ब फोर्स, यही सब कोई ना कोई एक फोर्स आपको, जब आप सर्कुलर मोशन में हो तो कोई ना कोई एक फोर्स आपको सेंट्रीपिटल फोर्स की तरह एक्ट करेगा। Here what I am saying, that whenever a particle is in circular motion, in that case some forces like tension or a spring force or gravitational force or Coulomb force or friction force, this acts as a centripetal force, right? So here this is very important. Now here magnitude of centripetal force, here magnitude of centripetal force is nothing but mass into acceleration, centripetal acceleration. Centripetal acceleration is mv square by r, so mv square by r, or we can write this as m omega square r, because v is r omega. Now this distance is, let's say, r. And here direction, so direction of centripetal force is radially inward. Now see here particle velocity in this direction, so perpendicular to this, here we will have centripetal force. Again, if I have to find centripetal force here, so perpendicular to this and radially, this is radially inward. So here again centripetal force, here also this is radially inward, again here this is radially inward. So centripetal force is acting always radially inward. So this is again very important. And here its magnitude is mv square by r. Now here I have taken few example. Here earth is revolving around the sun, so that means here one force, that force is here gravitational force. So here gravitational force, it is attractive in nature. So here this gravitational force is responsible for this circular motion. So in this case the gravitational force will act as a centripetal force. So here I am writing gravitational force acting as a centripetal force. And we know the magnitude of like gravitational force. So gravitational force is nothing but g m1 m2 by r square. So this is nothing but here centripetal force, and centripetal force we know mv square by r. So from here we can calculate the velocity of the earth, the rotational velocity we can find with the help of this. Okay, now here proton in nucleus, proton, electron are there. So electron is doing circular motion about this proton. So here the force responsible for this circular motion is here Coulomb force, OMB. So here this Coulomb force is acting as a सेंट्रीपिटल फोर्स. तो यहाँ पे कुलाम फोर्स एक्ट कर रहा है सेंट्रीपिटल फोर्स जैसा. एंड वी नो द फॉर्मूला फॉर कुलाम फोर्स. दिस इज नथिंग बट K Q1 Q2 बाई R स्क्वायर. एंड हेयर इट विल बी इक्वल टू सेंट्रीपिटल फोर्स. एंड सेंट्रीपिटल फोर्स इज नथिंग बट mv स्क्वायर बाई R. सो अगेन यहाँ इस इक्वेशन से हम इस इलेक्ट्रॉन की वेलोसिटी हम फाइंड कर सकते हैं. तो यहाँ पर कुलॉम्ब फोर्स एक्ट कर रहा है एज अ सेंट्रीपिटल फोर्स. ओके, नाउ हियर नेक्स्ट एग्जांपल. हियर आई हैव दिस थ्रेड एंड इट इज अटैच्ड विथ बॉल मास m and it is in a horizontal plane. Now this is let's say rotating. I am rotating this like this in a horizontal plane only. So in this case there will be tension in this thread or in this string. So in this case this tension will act as a centripetal force. So here I am writing tension in a string will act as a centripetal force. So here tension will act as a centripetal force. Its value will be mv square by r. Here this mass m is moving with velocity v. So यहाँ पर ये टेंशन फोर्स एक्ट कर रहा है सेंट्रीपिटल फोर्स. जैसे सेंट्रीपिटल फोर्स एज सच कोई नया फोर्स है ही नहीं. तो पहले केस में ग्रेविटेशनल फोर्स एक्ट कर रहा है एज अ सेंट्रीपिटल फोर्स. इन दिस केस Coulomb force is acting as a centripetal force. Here tension is acting as a centripetal force. Now in this case, here in circular path car is moving. So let's say car has a velocity v. So यहाँ पर if I want to draw free body diagram of this car, so here like this view I am drawing here like this. So downward direction have mg, then here normal force. Now here it will be friction force, because friction force in this direction. Why? Because here the car has a tendency to move out this way, right? So the friction will come into picture and it will try to balance this. So in this case this friction force. So here I am writing friction force acts as a centripetal force. Now we can write friction as a centripetal force. So m v square by r, and this friction we can write as a mu into n, and here n is nothing but mg. So friction force is mu mg. So here again I am writing here. So can I write here mu mg equals to mv square by r. So from here we can find the velocity of the car. Okay, next. Here I have taken one example of this death well. I hope you have seen like this. So here what is happening? Here this bicycle, na? So here there is a contact. So here contact force I am drawing here. So here this is contact for normal here. Here it will be like mg. Here in this direction will be friction. So here in this case normal force will act as a सेंट्रीपिटल फोर्स. तो इस केस में नॉर्मल फोर्स एक्ट कर रहा है सेंट्रीपिटल फोर्स के जैसा. एंड हियर वी कैन राइट दिस फ्रिक्शन फोर्स शुड बी इक्वल टू और मोर देन mg. तब ये नीचे नहीं गिरेगा, राइट? अदरवाइज इट विल स्लाइड डाउन. सो फ्रॉम हियर एंड दिस नॉर्मल फोर्स इज एक्टिंग एज अ centripetal force, and this is equals to mv square by r, right? Clear? So again this friction force I can write is mu this much only. Here it is needed this much only. Friction force is nothing but here mg. Okay, so and in this case this normal is acting as a centripetal force. Okay, so I hope this is clear. Now the term is centrifugal force. So here centrifugal force, it is a pseudo force. It is a pseudo force. I hope you have idea, right? So when when I want to convert non-inertial frame of reference into inertial frame of reference. So in this case we have to apply pseudo force. So in this case, here magnitude of pseudo force, here pseudo force is nothing but centrifugal force only. So centrifugal force, it will be same as magnitude I am talking about, same as magnitude of centripetal force. Now see here like if in this example, if I am seeing from here, that means my observer is at here. So in this case observer is at rest, right? So with respect to here observer A, I can write here this friction force, and here this friction force will act as a centripetal force, and it will be equals to mv square by r, right? So this, so I am applying here, my observer is at rest, that means I am applying this equation in inertial frame of reference. Now in second case I want to apply, or I want to use this pseudo force, centrifugal force. So what I will do, so in second case what I am doing, here on this car itself, I am like keeping my observer. So here on this car itself I am keeping my observer. So with respect to this observer B, what it will feel, ये कैसा फील करेगा, ये ऐसा इसे लगेगा कि ये जैसे इधर बाहर की तरफ जाने की टेंडेंसी है, राइट? बिकॉज हियर कार इज टेकिंग अ टर्न, राइट? तो इन दिस केस व्हाट आई विल डू, इफ आई वांट टू राइट here all forces, na, so I have to like write another force. That force is nothing but here pseudo force, and the pseudo force is here mv square by r, and this is nothing but here centrifugal force. So this is centrifugal force here. So in this case I am drawing free body diagram. So here it will be friction force, in this direction this is centrifugal force or pseudo force here, pseudo force. If I am applying pseudo force, now this frame of reference has become inertial frame of reference, and here if I draw like this, so here will be mg, here n, in this direction friction force, and is this direction pseudo force, and here pseudo force is centrifugal force. So I can write from here n equals to mg and f equals to mv square by r. I hope this is clear, huh? So here this is a centrifugal force. This is nothing but a pseudo force, and it acts here. Direction of this pseudo force is radially outward. Here also you can see, here the direction of this centrifugal force is radially outward. So this is mv square by r, magnitude is mv square by r, and direction is radially outward. So in first case my observer was here, so that means my observer was at rest, that means I am in a inertial frame of reference. Now in second case I am keeping my observer on this car itself. So in that case, in second case my observer is in a motion. So in that case this is non-inertial frame of reference. So to make it inertial frame of reference I have to apply one force, that's pseudo force. So here pseudo force is mv square by r, and here I am drawing free body diagram. With the help of this I am able to find here velocity. With the help of this now I can be able to find velocity, because here this friction is nothing but mu into n, and n is nothing but mg, so mu mg, like this. So from here we can calculate velocity. I hope this is clear of concept of centripetal force and centrifugal force. Okay, so thank you so much.